Well, good morning. Today's lesson is day one of student activity sheet 4 in the book, Sampling, Design, and Methods. So the bell ringer starts. What is meant by the population of spud potato chips that you are interested in testing? And what factors must be considered when selecting a sample? Let's think about this for a second. What is meant by the population of spud potatoes? Are we talking about the ones coming off the line today in the manufacturing plant? The ones that came off the plant yesterday, that came out of the plant, the ones that came out, that'll come off the plant's line tomorrow. The population of spud potato chips. But think about what the word population means. Population means what is the entire group made of, okay? So that means all potato chips that have ever been made, that are being made, and that will ever be made. So it's really hard to describe what spud potato chips, what the population of that is, because they've been making potato chips for X number of years, and we don't know how many more years they're going to continue making potato chips. So determining the population of spud potato chips, really, it's a difficult concept. So this is why we take samples. This is why we take samples of a population. And when we do a census, we try to do an entire gathering of every bit of information. A census is the gathering of information of the entire population. A census is very specific, and we'll discuss that. That'll be one of the words we'll have to remember for the test, is census. But in this case, the population of spud potato chips is all potato chips that have ever been made, or being made, or will ever be made. And so if we're interested in testing a very particular brand, then we're talking about that specific brand, that specific flavor. That population needs to be narrowed down by those parameters: the flavor, the size of the package, and maybe even we might narrow it down to when it was made. So those are the factors that we need to consider when we select a sample. So those are all the reasons we need to look into this carefully, okay? So let's talk about good things. Good things. Yesterday was our first day back. We all had a pretty good holidays. I've talked to many of you, and I think the good thing is that we actually decided that we came back better people. I guess that's the best way to look at it. So that's our good things. All right, so let's recall the spud potato chip scenario from student activity sheet 1. You hypothesized that the true mean weight of bags of spuds might be less than 28.3 grams advertised on the bags. Now, I want you to discuss amongst yourselves now, if you get the opportunity, or just take some notes on how you might collect a sample of bags to test your hypothesis. You're thinking about how can your sample be selected to be a representative of the population that you seek to actually test. So a representative of the population, notice that I'm moving my cursor around. It's very important to understand what is a representative of the population. So you want to set up all the demographics of that particular spud potato chip bag. You don't want to measure the 37.5 gram packages, and you don't want to measure the 11.3 gram packages, just the 28.3. So if it doesn't have 28.3 advertised on the label, there's no reason to test it. So that would be a representative of the population you seek to actually sample. It might be a specific flavor. It might be during a specific period of time in the plant when they were making them. It might be somebody's error in the plant, and that might be something you want to check on in quality control. So this leads to another circular relationship. You want to know something about a population, you have to choose a sampling method and obtain a sample. Collecting data from the sample provides some sort of estimate or conclusion about the population of interest. So we want to test a population. So we want to design a sampling method that creates a sample that is representative of the population, that helps us to get a good, accurate estimate and come to an accurate conclusion. If not, we'll go back to the population and design a different sampling method to create a sample that'll get us a better estimate or conclusion. There's lots of things that might actually cause problems with the sample, and we'll talk about those after we get back from the holiday break. In the meantime, we're looking at how to design the sampling method, okay? All right. Now, it may seem that the hard work in statistical investigation comes during data collection, but in all honesty, the other 4 boxes in the research cycle are the same size as the collect box. They require the same time and the same attention as the actual data collection. So it's kind of important to understand that. Let's see. In particular, researchers cannot skimp on the time and care they give on planning sample selection. If the sample is not representative of the population, results are going to be worthless. So like I said, if you can't get a sample of the population that you can collect data on, you're not going to get an accurate assessment, an accurate analyzation. You're not going to be able to report accurate findings or an accurate conclusion. And so what's the point of spending all that money to look at the question, design a model to sample a population, collect that sample, and then analyze it only to find out all that effort you took into doing all this was worthless? So it's really important to design a good sample that doesn't have any problems in it. We'll talk about those problems later, okay? All right, recall 2 of the teachers from the SAS 1, Student Activity Sheet 1, who are interested in the best test format for student achievement. Mrs. Johnson flipped a coin to decide whether a student would take a multiple choice or fill in the blank exam. And Mr. McDonald asked students which format that they preferred. These teachers chose to study the population of all students in their classes. This approach is called a census. Now remember, I told you that word's very important. If you're going to actually study the entire population, that is called a census. If you're doing just a sample, that's a sample experiment or a sample observational study. The U.S. government conducts a census every 10 years. What do you know about the U.S. Census? Think about some things you might know. Let's talk about this. A census, this slide is very important. Counts every person in the country. It collects information about these people. It collects the information about the household, how many people are in it, the ages of the people, the race or ethnicity, the income, the marital status. The census is very expensive. It's very time consuming, and it's never accurate because some don't participate, some are hard to find, and some move during the census. Well, let me ask you this. Is it difficult for them to count the people as American citizens that are in the military? Actually, in this case, counting the people in the military are not hard to count. Everybody in the military knows exactly how many people are in the military at the very moment. So they are all counted as American. Most of them are counted as American citizens. Those that are immigrants that come in and join the military, generally when they finish their service, they're given citizenship for their service in active duty. So anyway, very expensive, time consuming, and it's just to get demographics of the United States, and that's all it's for. A lot of other countries do it too. All right, now rather than go through the time and expense of a census, researchers usually choose to sample the population. There are a variety of sampling techniques. Let's define the following common techniques with help from your teacher or by researching other resources. What is simple random sampling? Randomizing who you choose from the population to actual sample. Well, let's just say we want to sample 10 students out of the senior class of Rudder High School. If you're going to randomize who you select, you're going to put all the names of seniors from Rudder High School into a hat, and you're going to pick out 10 names. That's simple random. Researcher chooses a sample from the entire population through some randomization technique. For example, drawing names out of a hat or using a random number table or a random number generator. Now, some of you may be familiar with a random number generator, but you've probably never heard of a random number table. With the advent of computers, we are able to create random number generators. And you might not know this, but there's really no such thing as a random number generator in computers. There's a specified sequence of numbers that it goes through. I don't know how to explain that, but it's true. You cannot randomize in computers. That is impossible. All right, stratified random sampling. What's the difference? Think about the word stratified. In geology, we talk about stratified layers of ground. If we dig in and we can see different layers of the ground, we can see different geological events that happen. They're layers and they're stratified. Strata means that there's layers. So in random sampling, if we're going to stratify, we're going to stratify the sample into layers or into groups and then randomly select them. So a researcher separates population into a number of strata, statistical subpopulations, and takes a random sample within each stratum. That's singular for the plural strata. Okay. Examples of possible strata are freshman, sophomore, junior, and senior classes, or males and females. So subpopulations, and you take a random sample of each one of those. Systematic sampling. What do we think that is? Well, I mean, what's the word systematic mean? It means there's some system involved in creating whatever you're doing. So in this case, a systematic sample, we use some kind of function or some kind of means to determine who is in the sample out of the population. So for instance, separates population into evenly sized groups, randomly selects one participant in the first group, then selects every nth participant. For example, the entire student roster is numbered. Numbers 1 through 25 are placed in a hat, and a number is drawn. Say the number 7 is chosen. Every 25th student afterward is selected. Our sample consists of number 7, 32, 57, and so forth. So the number 25 is actually chosen. Every 25th student afterward is selected. That's the system or formula they use to create that particular group. So let's go back. Separates the population into evenly sized groups. Randomly selects one participant in the first group. Now here's the thing. In systematic sampling, I do not want to get you confused about that separating population into even-sized groups. That is not a mandatory thing in systematic sampling, okay? We can say all we've done is put all the population in there. We're going to pick the 25th student or the number 7 is chosen. And then every 25th student afterward is selected. So we don't have to actually put them into groups. We can do this. We can say, okay, all 1,273 students are in this hat. We're going to pick the number 7. Okay, all the numbers are given a number 1 through whatever the number I just said. And then every 25th student after 7, 32, 57, the next number would be 82, and so on. You get the idea. So that's how it works. And it's just a formulatic method or a systematic method to sample the population. So this separating the population into the size group, this is not a mandatory. And it'll come into play later. You'll understand why. Cluster sampling. This is a group separation method. Separates population into groups, randomly selects some of these groups to participate. For example, the numbers of every classroom in the school are placed in a hat. 5 of those classrooms are selected, and every student in those 5 classrooms participates. So cluster sampling is just a bunch of subgroups out of the entire population of what you're seeking to research. And then out of those subgroups, you actually just select a few of those subgroups and use those students or whatever, those participants in the entire groups, all those groups that we picked as part of the sample. All right. Convenience sampling. I'm pretty sure you can understand what this is. Whatever makes it easy for the researcher. And that's it right there. Researcher selects participants based on easy accessibility. For example, researcher stands on one location at the school and selects the first 50 students to walk by. As a convenient method for the researcher. All right, suppose the school board wished to see whether the age of the student affects test achievement. Testing coordinator separated the roster of high school students into freshmen, sophomores, juniors, and seniors, and randomly selected 20 students from each classification. She then flipped a coin to determine which test format each student would receive, and then compared the results as follows. Freshmen who took the multiple choice test compared to freshmen who took the fill in the blank. Multiple choice sophomores compared to fill in the blank sophomores, and so on through juniors and seniors. This would be considered what kind of method? Randomization still occurred because the testing coordinator flipped the coin to assign the test format to each student. The approach is an example of what type of sampling? It's stratified random sampling. Now, Let's go back. Stratified random sampling. Stratified. We separated all the population into strata, into groups. And since the testing coordinator divided the students into groups that were alike by grade level. So we stratified in different subgroups, and then we randomly selected which method of testing they're going to use. So that is stratified random sampling. Mr. McDonald expanded his study to the entire school. He collected a student roster from the office and used the random number generator on his calculator to select one of the first 50 students on the list. He then selected every 50th student on the list after this initial student for his sample. The calculator generated the number 32. Which students on the roster are the first 5 in his sample, and what type of sampling technique is this? Okay, so every 50th student after number 32. 32 is number 1. 82 would be number 2. 50 plus, that's 132, 182, and 232 would be the first 5, right? And what method is this? Of course, these are the numbers, 82, 132, 182, 232. So on, this is an example of systematic sampling. A fixed strategy or a fixed formula after the first selection was applied to determine students selected for the sample. Okay, so it is systematic sampling. All right, Coach Smith wants to know whether students would pay for the privilege of parking their cars in the lot closest to the school. So he surveyed students getting on the buses while he monitored bus loading each afternoon. What type of sampling technique is this, and what do you think of his plan? Okay, first of all, he went to the bus loading area every afternoon and surveyed the students getting on the buses. All right, that's pretty convenient method, right? So obviously the method he used is convenient, but what do you think of his plan? What is he seeking to find out? Would students pay for the privilege of parking their cars in a lot? And he's asking students that ride the bus. Well, of course, this is an example of convenient sampling because think about it. Coach Smith is asking students who do not drive to school, so they may have an opinion or no opinion or think it funny and say, yeah, charge for parking. I don't care. I don't drive. On the other hand, they may be planning to drive to school in the future, so they may vote no. You know what I'm saying? All right, a large university wants to find out whether it is adequately serving the needs of the students who live off campus. So it's surrounded by a large number of apartment complexes. The researchers randomly select 3 of the complexes that seem to contain a diverse group of residents who adequately reflect the student body as a whole, and they survey these residents about campus services. Now, what type of sampling technique is this, and why do you think the university chose this method? Explain your thinking. Now, some of you may think, well, it's pretty convenient to just go ask some specific apartment complexes, but there's no randomization to it, is there? So we know it's not the random kind of thing. He did separate it into group. What did he do? He just researched a few of those groups. If I'm not mistaken, that's called cluster sampling. You get a couple clusters of the subpopulation of the entire population, and you choose just a few of them. The apartment complexes act as clusters. The university selected a few clustered and surveyed all the residents. It's probably easier than taking a random sample of all off-campus students, which would require going to all the apartment complexes near campus and trying to contact a few students in each one. So cluster sampling has some advantages over some other methods. All right, recall the research from Student Activity Sheet 1 in which scientists analyzed the scalp hair samples from 22 participants with epilepsy and 23 without it. They're checking for differences in levels of copper, iron, zinc, magnesium, and calcium. They were concerned about previous research that showed conflicting results. They speculated that other differences in the study group, besides the presence of or absence of epilepsy, could have caused these mixed results. Now, they attempted to control some of these other differences by gathering all participants from the same region of Turkey, which indicated similar dietary habits, and separated the participants into the following groups: males with epilepsy, males without epilepsy, females with epilepsy, and females without epilepsy. What kind of sampling is this, and what do you think? Well, we separated into groups, right? But did we choose just a few of those groups? No, we didn't, did we? So this is stratified sampling. Notice it's not stratified random sampling. All right, separating the sample into like groups of males and females. There's a little bit of difference between stratified sampling and stratified random sampling. The random comes in when there's some randomization method used to determine who's in the sample group. All right. Remember the study that tested the effect of replacing a rabbit's soybean diet with GLM? 25 young rabbits were selected randomly and assigned to receive either 0, 5, 10, 15, or 20%. Suppose rather than a random assignment, the scientists chose the following method. The assistant who was in charge of gathering rabbits went into the barn and assigned the first 5 rabbits he could catch to the 0% group. Then the next 5 he caught in the 5% group, and so on. What type of sampling technique is this, and what do you think of this plan? Okay. He went and captured the first 5 he could capture. Well, that was kind of convenient. There you go. It's a convenience method, or the sampling method called convenient sampling. Now, the research assistant could be catching the 5 slowest rabbits, so the slowest rabbits are getting the lowest treatment, while the fastest rabbits are getting the highest treatment. This approach introduces another variable that could affect the results. Think about it. If you're trying to get weight gain from a specific dietary supplement, and you're conveniently selecting the sample by catching the easiest to catch and giving them the least amount, you'll never really get, what's that word I'm looking for? The sample that is representative of the population. Remember we talked about in the first slide. You need a representative of the population. A sample that's not representative of the population is not going to give you good results to analyze. So this is probably going to introduce some variables that's going to affect the results. So it's not representative of the population. You want to select slow and fast rabbits for each one of those groups. So during busy political seasons, many opinion polls are conducted. In a presidential race, how do you think the participants in polls are generally selected? Discuss any issues regarding simple random, stratified, systematic cluster, and convenient sampling in these polls. What about other types of polls besides political? Now, here's some things you need to consider. Do you sample from all people, all citizens, all voters, and so forth, simple, random, or systematic? Sometimes pollsters stratify by income, race, or geographic location, which is called stratified sampling. Sometimes news reporters interview people on the street. That's convenience. And they may even use cluster sampling of groups of people around the country. Now, television and internet polls often ask for people to call in or log on to give their opinion. This generally attracts only people who are really for or against the topic in question. Formal and informal polls can also be collected from market research groups for advertising purposes. That happens a lot. Now, I'm going to launch you with this. The Cato 2017 Free Speech and Tolerance Survey, a new national poll of 2,300 U.S. adults, find that 71% of Americans believe that political correctness has silenced important discussions our society needs to have. The consequences are personal. 58% of Americans believe that political climate prevents them from sharing their own political beliefs. Democrats are unique, however, in that a slim majority, 53%, do not feel the need to self-censor. Conversely, strong majorities of Republicans, 73%, and independents, 58%, say they keep some political beliefs to themselves. Now, what do you think that is? I'm not going to really think much about this, but you can see the demographics here from the Cato Institute, this Free Speech and Tolerance Survey. Note the note at the bottom, among those who have an opinion of the news source. Now, what about those that don't have an opinion? Are we really getting a demographic of the people in our country? If we're not asking everybody, it doesn't matter. Now, look, they've separated this into liberal bias, people that lean far left, and conservative bias, people that lean far right, and people that kind of ride the fence. They're in the middle. They're balanced. So, for each of the following media outlets, what do you say are balanced in their reporting and which show liberal bias or conservative? They talk about these different things. Notice that they say that there's a conservative bias or a liberal bias. So MSNBC says there's a huge liberal bias. New York Times, and as you go down, get down to Fox, it has a huge conservative bias. I would venture to say that a lot of these are dead on accurate. Notice your local news TV station. It's got a lot of balanced idealisms. What's sad about this particular study is that in journalism as a whole, all of the journalists should be completely objective. They should be balanced all the way across. And as you can see, hardly any of these are balanced. The closest we get is your local TV news station. And I would venture to say that around our area, the local TV station that we deal with here in the Bryan College Station area probably lean a little more to the conservative bias. And if you don't believe we're biased around here, open your eyes or put on some glasses. So anyway, love to talk about this stuff. That's not what the lesson's about. It is about sampling methods and design. Do you see something wrong with the way they did this study? Note the note down at the bottom. They actually give a disclaimer among those who have an opinion of the news source. They're only asking people that have an opinion of these specific media companies. Okay? So if you don't have an opinion, we don't really get an accurate assessment. Although if you don't have an opinion, if you don't know anything about them, it's hard to give an opinion. So they actually probably did do the right thing by asking people to have an opinion. Even though that is given as a disclaimer or a note, I don't think it's a big deal. Anyway, there is an assignment in the Google Classroom SAS 4. You will not get it until after the second lesson. That is tomorrow. So you get a break today. No assignment. That will be tomorrow. In the meantime, be blessed and be a blessing, and I'll see you in class, folks.